We've got a really, really incredible lineup tonight. And for starters, we've got Andrew Sun, if you want to come on up.
We've been trying to get Andrew to do something with DATLAB for a while, but not fully based in NYC, but was here for the summer. And that was incredible. But we're already behind, so I'm not going to speak too much because I want to have time for some other stuff later. So, Andrew, take it away.
Yeah. I think one of the things, I feel like a lot of times artists will hear the combo of like math and programming, and that sounds super intimidating, but Andrew just has this really amazing way of working with math and also like making it approachable in a way that just, I feel like, makes it available to a much broader audience, which is amazing. And also, seeing a lot of parallels of that in nature. So I feel like their work with math and computation, but to be able to produce these pieces that feel really inspired by nature has been, a huge influence on my end. So give it up. Huge round of applause for Andrew.
Hello.
Hello. Do you want a mic stand?
I don't know if this is going to hold it, actually. Hello? Wait. I think it's good. I think we're holding it. Okay. Right. Awesome. Hi guys. My name is Andrew, and today I will be talking about parametric equations in TOPS, or texture operators. It's one of my favorite ways to make art.
I might have to hold it a little closer.
With mathematics. And is this good? Oh. Hello.
I think just being close to that'll be better. Yeah.
I don't know.
We're getting the mics sorted. Don't worry.
This is good.
Should be on. It's just the very top right here.
Oh, the on button. Okay, awesome. So, a bit of background, if you don't know what TOPS are, if any of you guys have been ever dabbling in TouchDesigner and you've come across this guy named Takara 12, that's basically what my art is. I learned a lot from him through TouchDesigner, and he's probably one of my favorite creators, and I would not be here today if it wasn't for him. One second. Okay, so yeah, a little bit about me. I've been doing TouchDesigner for almost 2 years now. I started in September 2023, and it was something I picked up as a hobby. I still would consider myself this being my biggest passion, and I just make a lot of art using math equations. I don't think they're super crazy graduate level math. It's pretty high school stuff. I like to think of myself as a glorified graphing calculator. And yeah, I hope that what you guys can get from this presentation today is a bit more understanding on why mathematics is kind of a really fun way to make art. I teach math a lot. I did it as my part-time job when I was doing my undergrad at UBC, studying mathematics. And yeah. Anyways, so a little bit of backstory before I get into the meat of the presentation is with this image right here. I gave my first presentation on TouchDesigner last year, June 2024. And it was this presentation on Jellyfish. And it was at this portion of the presentation where I really stopped and I was like, oh, this is not common knowledge. And I was at this point of the presentation, and there was this function top right here. And it's just a gradient, but as I'm giving this presentation, I confidently say, this is a circle, obviously. And I don't know, if you're not, oh, is this? Oh, Hold on. I think the screen is frozen. Oh, wait, hold on. Okay, great. Yeah, and I was like, okay, this is a circle, obviously. And like, obviously, this is not a circle. And like, even if you are someone who dabbles in comp sci or can, understand how math equations work, when you look at this image, it's not gonna immediately come to you that this is a circle. And it's like kind of really interesting to like think about, well, like, why is this a circle? And when people at that presentation were like really confused, I was like, okay, let me like try to figure out how to explain this gradient and a lot of what I do in TouchDesigner. But before we even get into that, I think the first thing that we should ask ourselves is, well, what is an image, right? What is a texture? And to me, a texture is simply just a method of storing information. And with most images, there's 3 channels, or like 4, but like I'm gonna stick with 3 because I don't really use an alpha channel. But there's the red channel, there's the green channel, and then there's the blue channel. And with these channels, essentially, you can label every single pixel. And you can sort of categorize that pixel of an image, say like a 20 by 20 pixel image, into 3 lists: the red channel, the green channel, and blue channel. And in TouchDesigner, we do that with normalized color data. So it ranges from 0 to 1. Conventionally, I believe it's usually 0 to 255, but in TouchDesigner, we have it normalized. And this is very, like, when I found out about this, I was like, wait, this is like kind of awesome, because like a red channel, a green channel, a blue channel, like what else can we associate with that? Like, we can also say that these are coordinates in 3D space. We could just say, oh, the red is the x, green is the y, and the blue is the z. And so you can end up with these fun little graphs of your image. And even though this is a 20 by 20 pixel image, you can go as crazy. But all you need to know is that every single pixel is a point. So we end up getting 400 points of normalized color data plotted in 3D space. And when I discovered this, I was like, okay, this mapping between an image and 3D space is really, really fun. And so I asked myself, like, what's the reverse? And to me, the reverse is, okay, well, how can we draw something in 3D space and then get the color? And my discovery was parametric curves. And so before we even get into parametric curves, we should talk about functions. And functions are just a way to put an input, right, and then get an output. I like to think about it as a conveyor belt. And so this function is f of x is equal to x squared. And our input, we can think of it as our red channel. And we plug in x equal to some number. Right now, it's going from 0 to 1, and it's just growing. But you should notice that our red channel is going from, it's going from 0 to 4. And then our green is growing at x squared the rate. So when we're at 4, we're at 16. And essentially, this mapping, we can display it as a gradient. And so this gradient right here, if you just sort of keep an eye on the top of the texture right here, the image, it maps directly to the first index of, or the first row of our table. And so here, right, we see that as our image grows in size, like the values being from 0 to 1, the more yellow it gets. And hopefully this makes like a bit of intuitive sense, because when you mix red and green, you get yellow. So at the very top of this image, we're getting values that are like red is 1, and then green is even, like it's also 1. And what we can do also is we can split the texture into its corresponding colors. And so this time around, instead of mixing it, we're just separating it. And hopefully, it's very subtle, but what you can notice is that this red gets brighter, not as fast as this green. Like this green goes a bit, like it gets brighter a bit quicker. And the reason why is because this rate of growth of red is x, and then this rate of growth of green is x squared. And so that's where the gradients come from. It's this slow but consistent growth. And so, well, what does that look like as a graph? Well, as a graph, what we're doing is as we're sort of scrolling downwards, our pixel is representing a space in 2D coordinates. And that position can be represented as a parametric curve. And a parametric curve is basically separated into, I guess, like 3 parts? Yeah. So the first part is the functions. So we say that our red is a function x of t, our green channel is our y of t, and our blue channel is our z of t. And so from there, we also have our range of t, which is from 0 to 1, and then our graph down here. And yeah, so right here we have our image, or our texture as like a parametric curve gradient, and then here I split it up into its 3 corresponding channels. And so for this one, our blue channel is completely black because we've defined it as so. And once we are able to do that, I think we can really break down a lot of gradients in TouchDesigner. And the most common one, the most common parametric curve in TouchDesigner, to me, is the ramp top. And the ramp top is just a linear interpolation, y equals x, but in all 3 channels. And so what you get is you get this straight line that kind of just points into the space of 1, 1, 1. And yeah. But we don't need to keep our equations so simple. And we also don't need to keep our t domain from 0 to 1. We can change it up and give our red-green functions more complex functions. And in this case, I've decided to go with the cosine of t and the sine of t from 0 to 2 pi. And if you know any trigonometry, that's essentially the equation of a circle. And the same thing goes, as we scrub through t, we're going downwards. And when we go downwards, we're sort of picking out that one individual point around that curve. And this is fun because, well, now you can quite literally go like as crazy as you want, and you can make as many like fun curves. And not only do you get something goofy on the right-hand side, but you also get something very, very pretty, at least in my opinion, like just like a really interesting texture, which is like a bunch of random colors and it's like pattern. And yeah, to me, I think that that's like the association is like really fun. Like you have 2 2 outcomes of art out of one creation. But so one thing that I think is like really interesting though is that these textures can hold multiple parametric equations. And what I mean by that is when I define this image to be a parametric equation or a parametric curve, right now, t, I'm only considering traveling t, right? And what I mean by that is t goes down vertically. No matter what point of this texture image that I start at and I go down, I'll always get the same circle. Like if I'm here and I'm going downwards, I'm gonna go and travel the circle. If I start a point like right here, it's gonna be the exact same thing because we have nothing defined for the horizontal direction. And so when I sort of like figured that out, I was like, okay, well that means that we can include another variable. And that variable will traverse horizontally. And so now, well, what happens if we decide to like multiply this entire image with another ramp, right? And so now, if you don't know trigonometry, the parametric equation of a curve, the radius is dependent on the value in front of the cos and the sine. And so for this version, we're just multiplying with u, and this u goes from 0 to 1 right here. And so as we're going outwards, we're increasing our circle. And this is one way that you can create a disk using a texture. And so the difference now is that, okay, if I start here on the image and travel downwards, that means I'm going to be traveling a smaller circle compared to if I'm starting here and traveling downwards. Now I'm going to go and trace out a bigger circle. And this is fun because now I get like an entire new dimension to like work with and sort of define my curves. But it's still in the same image. We're not like leaving that. And so now a lot of our creations can get even more complex because we can decide where to travel. And so for this one, right, I made a cone because my blue channel, I decided, okay, we're gonna travel the z-axis all the way to 2. And this is a new layer of complexity because now we can really like add whatever variables we want to our parametric curve, and we'll get like a pretty interesting 3D shape. And when you do something like this, it's still like contained in one image, and at least to me, it's pretty fun to sort of like think about the cases on like where you are. And so for here, I made the red circle being u, right? And then our t is that little blue path right here. And so right now, this animation is kind of going down like this. And yeah. And once I figured that out, I was like, okay, well, jellyfish are like pretty simple. I start off with a circle, I'm traveling down a curve. It can't be too hard. Yeah, so back to the cone. So what I thought was like, okay, well, if I have a method to sort of grow a circle out in one direction, then why don't we just start off from there? So I have a chain of circles that I want to grow out from that x-axis. So I just want these circles to follow this curve right here. And when I do that, I get this cone, just like we saw before. But then we can think about this a bit more and be like, okay, well, what if we don't want it to just go linearly? Let's make it a bit curvier. Well, then we can do that. And now the shape of the growth of the circle of each individual circle follows this curve. And that's our jellyfish head. Like, wow, that's so like straightforward to me. And then like, but like the bottom is like a bit too flat. So I was like, okay, well, what if we add a bit of noise to our starting circle? Well, that means now every single individual curve has a different ending point based off of the noise. And now we have like a bit more of a, like an organic spread that we might see from nature. And down here is what that starting circle looks like when we add that noise. And so, well, we can also get the tentacles. And the tentacles, we're just still going to take that original circle. But what we can do is we can consolidate all the points into certain areas, right? And by doing that and then adding a bit of noise to each position of that point, we can then do the exact same thing, which is make the U direction travel down the Z-axis. And we get these little line strips. And when we get that, well, what we can do is we can add more more noise onto the tentacles, and then we get like these tendrils. And so now we have our jellyfish. It's completed. It's 2 textures, and that's it. And yeah, and then you add them together, and you get a little jellyfish. And so you have your jellyfish on the right-hand side, which is the parametric curves, but then you also have 2 little images that represent that jellyfish. And I think that's really, really great because, well, if you know anything about instancing in TouchDesigner, because I'm playing around with parametric curves and the way that they are defined is horizontally and then downwards, you can use ramps to your advantage because everything is sequential. Everything is ordered. You don't need to think about like check any conditions or ordering. It's already all organized from you because parametric curves start from 0 to some ending point. And that's really fun because what you can do is you can really, like, it makes coloring and scaling your point clouds really straightforward. If I want so here's my scale for this jellyfish. If I want my the tendrils of my jellyfish to not intersect, then I'll just make this part like black so that there's a 0 scale. And then now I have like 1 here, so they're all visible. And then I have a little taper down here so that they kind of shrink down. And then what you can do then is like if you want some wired effects of like electricity, all you have to do is like push your pixels downwards. And yeah, to me, I think it's just like a very intuitive, straightforward way. As long as like if your point cloud is organized, then everything else is organized, and you don't actually really need to think about like, oh, if this if this point is like too close to a center, then we can't color it a certain color, right? And yeah, and then here is like the head where I'm making the scale go downwards, and it's like growing and then shrinking, but then I'm also making the color go upwards. And because of this like interference pattern that's happening from the scale going downwards and the color going upwards, you get like a really, really pretty twinkling effect. But yeah, thank you so much. I hope you learned something today. That's my QR code if you want to support me on my socials or on my Patreon or check out my YouTube channel. I'm also very passionate about teaching TouchDesigner mathematics. Hopefully you could tell from that presentation I just gave. But yeah, so if anyone, I really would like to do a workshop before I leave New York City. So if anyone knows any venues, please let me know. And also, I'm also trying to become a professor at anywhere teaching creative technology. So if anyone can help me, like navigate that, or like I would love to just grab a coffee and just like try to like, yeah, that's my dream. But yeah, thank you so much.
Any questions from the audience? Yeah. Sure.
Oh, yeah. Sorry, it's really bright. Oh my God! You've got to be kidding me. Okay, hold on.
What'd you say? What was the question?
Oh, like my QR code is broken apparently.
Oh.
So.
Do it live. Oh.
Don't look at my network. It's ugly and terrible and not organized at all.
I mean, you just set yourself. I mean, it looks a lot like mine, honestly. Anyone else have any questions? I'm going to walk over to you with a microphone. Or kind of jog.
Those are my socials.
Do you plan on reapproaching this? Hey, Andrew. Hi. Hey.
Hi.
Do you plan on reapproaching this with pops?
Um,
or has that made any sort of impact on like your own research or the way you want to present it?
So to me, as of right now, I haven't done that much. I think one of the things that is charming to me about TouchDesigner is the fact that you can program visually. Pops kind of like takes a bit away from that, but I am very excited because there's been a lot of good tutorials, and it sounds like collision detection has been a lot more optimized, and I'm like really excited for that. But for now, not really, no.
Hey, first of all, like super inspiring. I love how like elegant it is, and a lot of it goes over my head, and it inspires me to think of it like in terms of audio too, like how this kind of like the parameters of audio can maybe like be used for this. Anyway, yeah, I was like very inspired by it, but I'd definitely love to talk to you after because I have access to a venue and I can get you in touch with some people at like ex-professors if you want to like just have a conversation. But
Awesome.
But yeah, not really much of a question.
Thank you.
Anyone else? One more question, and then also if our second presenter wants to come up as well. Oh, everyone's at the front. Nice.
This is your request. Can you walk through this presentation TouchDesigner file, please?
I mean, like, it's. I'll just do like something really quickly. It's a bunch of components, containers, and then it's a switch, and then it's controlled by my Q and E, and then each one of them is using a bunch of op viewers, and yeah, it's just PowerPoint in TouchDesigner because I don't like to do anything else.
Oh yeah.
Yeah. All of them are live. Everything's live. I'm not recording anything. I make like posters and like my friend Freya, like she's a graphic designer, and like I've like shown her, I'm like, hey, I made this in like this like thing in TouchDesigner. And she's like, why don't you just use Figma? And yeah, no, I love TouchDesigner.
Woohoo! Thank you, Andrew. Thank you.